Hey everybody, hope you're all doing well. So in this video, I'm going to show you how to easily integrate 1 minus x squared all to the power half with respect to x. And the best way to do this is to use a bit of U substitution with some lovely trigonometric identities. So without further ado, let's go. So the first thing I want to do is let x equal sine u. The reason why is that, well, it's all going to play itself together. So let x equal sine u. Now if we to differentiate this, and what exactly happens? Well, we should get dx equals cos u, and of course du. Now if we were to replace this inside the original formula, you'll notice that x will become sine squared u, and the dx will become cos u du. So let's have a look at that. So now we have the integral of 1 minus sine squared u to the power half times cos u du. Okay, not bad. Now, I don't know if you guys can spot this, but have a look at this part here. Notice that this is actually a very famous identity, and that is, if we look carefully, something with sine squared, it will be the standard sine squared plus cos squared equals 1 formula. So sine squared u plus cos squared u equals 1. And that's it, guys. Now all you really want to do is literally rearrange this to make 1 minus sine squared equal to cos squared u. So subtracting sine squared u across, you're going to be left with cos squared u on the left hand side and 1 minus sine squared u. And that's it, guys. I think we're literally there now. So now we just plug in this quantity cos squared u for 1 minus sine squared, and then you can square root that. So let's do the steps. So now you got the integral of 1 minus sine squared is now cos squared u, and all of this is square rooted. So it's literally just cos u times another cos u du. And tidying this up, well, the square and the square root cancel out, so you're left with cos u. Then you've got cos u times cos u, which is this cos squared u. Okay, not bad at all. Du. And lastly, now this is the final step. So now we've got this integral here. In order to resolve it, we need to use the double angle, or the standard double angle formula, which relates cos to u. So suppose we say let the standard cos 2u equal, what is it? 2 cos squared u, no, not 2 cos. Yep, 2 cos squared u minus 1. Therefore, rearranging this equation, we can plus 1 and divide by 2. We should get a term for cos squared u. So cos squared u is going to equal plus 1 divided by 2. So 1 plus cos 2u over 2. Now, that's it. Now, all you want to do is just literally plug this back in and integrate it. So remember, this part here is the double angle formula. Now, let's plug this in back into the original formula, which is up here. So we should get exactly, let me just see, should get the integral of 1 plus cos 2u over 2 du. And notice that we can factorize the half because it's just a constant. So we're going to have now the integral, so take off half, so we've got the integral of just 1 plus cos 2u. And this, guys, is basic. So this is going to give us half, and an open bracket, the integral of 1 will be u. Let's write it down. So we've got u plus cos 2u becomes positive sine 2u over 2 because we differentiate inside 2. And then plus c. And that's it. Now all we want to do is replace u with the correct term. So we know that we let x equal sine u. That means u would be the inverse sine, the sine inverse of x. So we can say, therefore, half is now e. So u is going to be the sine inverse of x plus, sine, and then sine 2u. Well, let's have a look. Can we make something of sine 2u? Well, we can use, I suppose, the double angle, or nah, just to make our life easy. We can just let this term be plus sine bracket 2 times the sine inverse of x. You could use a double angle to resolve it, but I think for the sake of this video, let's just leave it at this stage because now we've integrated it. Plus c. That's it, guys. Expand and simplify, or there's many other alternative solutions, but I believe this is okay. And yeah, so if there's any strange errors you might spot, but let me know. Other than that, please leave a comment and let me suggest anything. I might sound a bit tired because I'm recording this at 1 a.m. Just wanted to really get this knocked out. So yeah, thanks for watching, and I shall see you in the next video. Ciao.